Hello and welcome to the OTB channel. Little bit of a tutorial today. How much do you understand file and directory permissions in Linux? Little bit? Not so much? Or is it a complete mystery to you? Well, in any of those cases, this might be quite useful because I'm going to go through how you can find out what groups and users are associated with files and directories, and how, if necessary, you can change them. See you after the intro. Okay, welcome back. For those who like my t-shirts, this one says, I went outside once and the graphics aren't that great. It's an old shirt. Today I thought I'd do a little bit of a tutorial rather than a review or something similar. I started thinking, most of us learnt Linux in the same way. We started using commands that, generally speaking, we'd got off somewhere online, be it a forum or wherever, and banging those commands into the computer without necessarily having an understanding of what we were necessarily doing or why those commands were important. And the understanding came afterwards. Well, based on the comments and requests from a whole range of users and viewers of these videos and from guys on my Facebook group, one of the areas where there doesn't appear to be a huge amount of clarity is this topic of Linux permissions for files and directories and what they're all about and how we modify them. So I thought today what I'd do is a little bit of a tutorial. For those people who already know all this, I apologize. You obviously aren't going to watch the video, but I'm hoping it might be useful for new users or users who are trying to learn the system. So I'm going to go through it in stages. It takes as long as it takes. Not so much a ramble, but trying to make sure that the information that you need to get to grips with this subject is sufficient. Anyway, see what you think. Let's get into it straight away, and I hope you enjoy the video and find it useful. So you should see in front of you the terminal now. And the reason I've got this up is I just want to start the conversation by talking a little bit about Linux itself and users and groups. At its heart, Linux is a multi-user operating system, and everybody knows about how secure it is. And that security is all based around the permissions that are attached to particular users and particular groups on the system. Now, when you think about users, you might think, well, I'm the only user of this system. There's not going to be any other users there, but actually you'd be wrong if you thought that. If I just type into this terminal, getEnt, which is a great little command for extracting a list of users or a list of groups, and I put in password, getEnt password, the terminal will return a group of users that are on the system. And you can already see that there's more than just me. There's obviously root as well, but various processes also have their own user. You can see I'm here, Steve. And what do these different columns mean? Well, put quite simply, I've got my name there, my username. The X there is my password, but it only shows up as an X because it's encrypted. And the next thing is my UID, and separated by a column is the UID of my default group, which, by the way, when you create a user, a group is also created generally that has the same name of the user as the user. So my name's Steve, and I also belong to the Steve group. You can then see where my home directory is and what shell I'm using. And this is pretty much the same all the way along. And let's have a look at groups. So we'll use the getEnt command again, but this time just put in the word group rather than password. And you can see that there are a whole range of groups here. Now, the important thing to consider is, although as a user in Linux, we are given a default group, and my group is Steve, and you can see it there. Hopefully you can see the mouse, and the group ID is 1000. Again, the X represents an encrypted password, but I'm not only a member of the Steve group. I am also, let's just run through this, I'm also a member of the Wheel group. I've gone through that in some of my other videos. I usually add the group Wheel to my username, or I become a member of that group to make it easy to set up sudo. We then have users. There's a group called users, which I'm also a member of. And what else down here? I'm a member of the VBox users group as well. Those of you who use VirtualBox will probably know that VirtualBox sets up its own group, and in order to use VirtualBox properly, it's necessary that you add your name to the VBox users group. So, on any Linux system, you are going to have a set of users, you are going to have a set of groups. There is a default group that each user will belong to, but a user can belong to multiple groups, not just a single group. Right, so users and groups are really important in terms of understanding how permissions for different files and different folders work on the system. In fact, every file and folder is associated with a particular user and a particular group. Let me just move to the split screen and I'll expand on what I've just said. Okay, so you should see a slide in front of you now. It's important to remember when we're talking about file and directory permissions, there are 3 core permission groups on a Linux system. Now, we've touched on the owner of a file because we've talked about users, and every file or directory will have an owner, and that owner is usually a user. It will also have a group owner. By default, the group associated with a particular file or directory will be the default group of the user who owns that file or directory, but it doesn't necessarily have to be. So, for instance, I could create a file and by default, Steve, the user, would be the owner. By default, my default group, Steve, would also be associated with the ownership of that file or directory. But then there's another category. Let's call it other. What it essentially means is everything else, every other group and user that is not associated with ownership of that file. Okay, so there's those 3 permission groups. And we expand on that then by talking about, well, what are the permissions that are given to each of these ownership groups, for want of a better term? Well, it can be split into 3 basic permissions, and they are read, write, and execute. Simple. So an owner can have read, write, and execute permissions, so can a group, and so can everybody else not associated with the ownership of that file or directory. So yes, I know this is a little bit like Linux Permissions 101. And for those of you who are saying, come on, OTB, Steve, or whatever you call me, I know all of this. Appreciate that. But I've had so many requests for this sort of thing. over the course of the last 12 months, we've hit 12 months now, by the way, that I thought it was well worth just going through the basics before we start to expand on this. So you know how to find the users and groups on your system. You know basically there are 3 categories of ownership, for want of a better word, and you know that the permissions are read, write, or execute. So how do we actually find out what permissions a particular file or directory has, and how do we know who the group owner is, the file owner? How do we know what group is associated with it? And how do we know what the permissions are? Let's switch to the terminal again. Right, so let me just make this a little bit bigger so that you can see what I'm doing. Okay, from my prompt you can see already that I've su'd to root here just to make things simple so I don't have to keep using sudo for this demonstration, and you can see that I'm in a directory called test. If I use the ls command, you can also see that there are 5 items in this directory, file 1 through to file 4, and something called test. At the moment, we don't know what the permissions are on any of these things. We don't know if there's a directory there. It could be test, it might not be. And we don't know what groups are associated with these things. That's dead easy to find out. You just do the long form of ls by adding the -l option. And we now see, in fact, let me just make this even bigger. And we now see the long format of ls for each of those 5 items. And looking at this immediately, I can see that all except one of those items is owned by me, Steve, but one seems to be owned by root. I can see what the permissions of each item are, and I can also see that there's a directory there, and the directory is this thing called test. How do I know this? Well, let's just switch back to the split screen. So you should see a slide in front of you, and what I've tried to do with this slide is to distill the output of the ls-l command. And I've separated it into 3 chunks. Right at the far left, we have something called the mode bit. And that's the part of the ls-l command that contains all the RWX characters. And they're important. They give you a lot of basic information. The first character identifies what type of item it is. If it's a directory, you'll see a D there. If it's a symlink, you'll see an L there. And if it's just a plain old file, you'll just see a dash or a dot if you use something like exa. Following on from that, the next 9 characters are to do with the permissions of the owner, the group, and everybody else. And they run from left to right. So the first 3 of those 9 characters specifies the permissions for the owner. And you can see here that the owner has read, write, and execute permissions. The group, which comes next, just has read and execute permissions. A dash means they have no permissions for writing. And it's the same for everybody else, the other group, if you like. Moving on to the next block, we're told who the owner is and what the group is that is associated with ownership of that file or directory. And in this case, it's me. It's Steve, and the Steve group is also associated with the ownership. And then last but not least, we have the name of the file. I've not included things like timestamps in here. I'm just getting to the actual core output. So this tells us what it's all about. And if we move back now to the terminal, that should make more sense to you. So you'll see here now, those 5 items that I ran ls-l on have the core information here. If we look at the first bits, we can see that There are 4 dashes for files 1 through 4 to let us know that they are a file. The 5th item, though, called test, is clearly a directory. We then move on to the next 3 characters, and for the 4 files, I can see that the owner has read-write permissions, but no execute permissions. The group associated with the files has read permissions only. They do not have write permissions or execute permissions. And for other, well, there's a difference here. In file 1, the other group has execute permissions, but they can't read or write to that file. But on the remaining 3 files, they have read permissions only, no write or execute permissions. And if we look at the directory, well, the format's the same. Owner, group, and other all have read and write permissions. So, all good. So, dead simple to see what's what on the system. The ls command gives you all the information you need to know. You can see who owns the file, what group is associated with it, and what the individual permissions actually are. How do we actually go about changing those permissions, though? Well, there's 2 key commands here. One is the chown or chone command, and perhaps more importantly, in terms of the sort of command that you're likely to use most of the day, is the chmod or chmod command. So let's talk about them in a bit more detail. So the chone command is used to change the owner and or the group ownership of a particular file or directory. And this is a command that I tend to use if, for instance, I've SSH'd into another system and I've taken a file from there, but the file isn't currently in my name, or it might be down as a root user file, and I want to change it into my name so that I can manipulate it and edit it. And the chown command, the syntax of it is pretty simple, actually. So if you wanted to change the owner and group of a file, let's say we had a file that was in, I don't know, Bob's name, with a group also called Bob, and that was file number 1, I would simply issue the command chown Steve : Steve file 1. And that would change the ownership and the group to Steve. So the first entry is the owner that you want to change the permission to, or the ownership to. The second entry is the group. You don't have any spaces between this. It's just Steve : Steve, and then the name of the file. If the file's already used by root, obviously you're only going to be able to do this with sudo, or if you su to get the permissions. You can also change the permissions on a directory, and you can change it in such a way that every file that currently is in that directory also has its owner and group ownership changed. And you would do this simply by using the chown -R command to recursively set directory permissions. If you just wanted to change the owner, leave the group exactly the same, well, that's even simpler. Just chown Steve file 1. So in that example I used before, where we've taken a file that has an owner called Bob and a group called Bob, if I issued the command chown Steve file 1, the output would be owner Steve, group Bob file 1. If I just wanted to change the group, well, it's similar, but I just put a colon in front of the group that I wanted to change. So taking the Bob example again, if I issued chown Steve file 1 and then did an ls-l, the file would show the owner still as Bob, but the group name now as Steve. Let me show you how this works in practice. Right, let's start by changing the ownership and the group of file 3, which is currently assigned to root. So all I'm going to do is I'm going to go Chone, and I want to change it to me, and I also want to change it to the Steve group. And I just type the name of the file. So Chone Steve file 3. At the moment you can see it's root, but let's do ls again. You can see it's now back in my name. Okay, let's just clear that. What about if I take file 1 and I want to change the owner to root, but I want to keep the group as Steve? Well, it's the same principle. Chone, root, Steve, file 1. Oops, file 1. And if I do an ls-l, you can see that's now changed it. It started off as Steve, it's now root Steve. What about if I wanted to just change the group name of one of these files? Let's take file 4. Currently, that's Steve and Steve. So I'd go Chone, root, file 4. ls-l. And you can see file 4 now has root as the group associated with the ownership of that file. Right. Let's move on to the directory. You can currently see that that directory is Steve. It's owned by Steve, and the group is also Steve. Let's just have a quick look what's in the test directory and see what the permissions are. And there is actually 2 files in there, file 5 and file 6. Both files are currently associated with Steve and the Steve group, but we want to change that. So in order to change it, I'm going to do a Chone -r to make it recursive, and I'm going to change it over to, let's do the root user, but the Steve group, and it's called test. So let's do a list L, and you can see that the directory is now changed to ownership by root, but the Steve group is associated with it. If I now do a list of the actual files in that directory, you can see that they now have the same ownership and group ownership attached to them because it's recursively changed everything. Changing the ownership of the files did not change the underlying permissions though. So if initially Steve was the owner and had read-write permissions but no execute permissions, and we changed that to root, those permissions would be exactly the same. So how do we go about actually modifying the permissions themselves? Well, here we use the chmod command to change what we call the mode bit, that little bit of information that we get at the very beginning of the ls-l command. It's not quite as simple as the chown command because there are 2 different ways that you can do it. You can do it symbolically or you can do it numerically. And this messed with my head for a long time when I first started. So let me try and break it down into how this actually works. I'm not entirely sure why we have 2 methods for chmod and what its history is, but essentially you can use both. Make your choice. I've become comfortable with the symbolic method just because for me it makes more sense. But if you prefer the numeric method, use that. But let's focus first of all on the symbolic method. So it consists of a number of components. After the chmod command, you would specify which group or owner it actually relates to. And you have U, G, O, and A representing the user, the group, other, and all. So you can do a chmod A, like I've done in this first example, which is referring to all, and I've done plus RW file1. What I'm saying there is allocate read-write permissions to everyone on file 1. In fact, the default for chmod is if you don't specify the A, it will default to A anyway. So you'll often, if you need to make a file executable, you'll have probably seen examples where people are saying just do a chmod plus X on the file, and that actually applies execute permissions for everyone. Or you can be a little bit more picky. So if we go down to the second one and we do chmod UG, we're saying apply this permission just to the user and group. And the permission we want to apply is X, but there's a minus there. We want to remove X executable permissions from the user and group, because following specifying who the command applies to, the user, the group, other, or everyone, we have to say, well, we want to add a permission, we want to subtract a permission, or we just want it to equal something. So in the first case, I added read-write permissions. In the second case, I removed execute permissions. We can also specify exact permissions rather than just adding or subtracting them. So if we move down to the third command, I'm just concerned here with the user, and I've said chmod u must equal rwx on file 1. In other words, make sure that the user has read, write, execute permissions. And so it would modify the file appropriately. Or I could specify it for every single element. I should say the user should be read, write, and execute, the group should be read, write only, but everybody else should just have read permissions. And we can apply that recursively just like we could with Chone. It'll make more sense when I show you in the terminal exactly what I mean. So here we are again. So let's have a look at our file list here. So I can already see, if we look at file 1 here, the owner has read-write permissions, the group has read-only permissions, everybody else only has execute permissions. If I wanted to give everybody execute permissions, I could just do chmod plus X on file 1. And if I do ls-l again, you will see that execute has been added for everybody. That is exactly the same as the command would be if I did chmod all plus X, and you have to add the file name after. So ls-l, it hasn't changed. Read, write, execute, execute, etc., etc. Okay, so let's clear that to give ourselves some space to work. Now, what about if I wanted to leave these permissions on file 1 exactly as is with an exception? I want to remove the execute permission for everybody else. I want the group to still have it. I want the owner to still have it, but everybody else, no, give them nothing. Well, that's simple as well. So chmod, and then I would specify everybody else, and I would minus X. And again, I'm missing the file name, file 1. And there you can see, file 1, everybody else has no permissions now. What about if I wanted to fine-grain it a little bit? Let me see. If I wanted to do chmod, say the user, I wanted it to be read, write, and execute, comma. I wanted the group to have read, write permissions, comma. And I wanted everybody else to just have read permissions. Oops, equals read. All on file 1. You can see on file 1 there, it's done that exactly. It's given read, write, execute permissions to the owner. It's given read, write permissions only to the group, and it's given read permissions only to everybody else. So I can use this mixture of specifying who I want the permissions to apply to, and then add or subtract permissions, or just state an absolute situation like here, where I want permissions to apply to particular ownership groups. Now, I said I use that symbolic method, and I think it's because you get used to using one method only. And if I try and switch over to what we call the numeric method, or the octal method, I think it's sometimes called, I can never remember quite how it works. But you may find it easy and more understandable. So you can use either or, but just for completeness, I'm going to cover exactly how that works. So let's talk about the numeric method. You should see this slide now in front of you. Everything on the numeric method is given a number. Fairly straightforward, really. And the numbers are here on the first line. For read permissions, you get a 4. For write permissions, you get a 2. And for execute permissions, you get a 1. For no permissions, you just get 0. So if you had all permissions, read, write, and execute, we would know that because you simply add up the different numbers. And if there's a 7 there, which is the result of adding up 4, 2, and 1, we automatically know that you have read, write, and execute permissions. If the number was 6, well, you'd only have read and write permissions. If the number was 5, you would only have read and execute permissions. And there's only one thing it could be, because these things only add up in a certain way. Now, those numbers, you work from left to right when you're specifying this with the chmod command, and they look a little bit like this. Chmod 777 file 1 is giving permissions of 7 to the owner, permissions of 7 to the group, and permissions of 7 to everybody else. So that's giving everybody read, write, and execute permissions. If we decided to kind of back off from that a little bit and only give the owner execute permissions and everyone else, including the group, just read, write permissions, read and execute permissions, this is why I don't use this method, it would be 7 for the owner, read, write, execute, and it would be 5 for the group and everyone else. And 5 comes from adding up read and execute. If we wanted to modify that further, we could specify something like 640. So this means the owner has 6, which comes from read plus write, so 4 plus 2, but the 1 for execute isn't there, so he has no execute permissions. The group has number 4. Well, 4 can only be read permissions. And everybody else has 0, which means they have no permissions whatsoever. Right, let's go and play about in the terminal and I'll show you what it means. So let's go back to the files that we've been using, and let's pick, let's pick file 4, just for a laugh. At the moment, we can see read, write permissions for the owner, read permissions for the group, and read permissions for everybody else are there. What about if we just wanted to blast it and give everybody all permissions? Well, let's do a chmod 777 file 4. I'm doing ls-l, and look, suddenly everybody on file 4 has got every single permission. What about if we wanted to remove execute permissions from the group and everybody else, but for the owner to retain it? Well, similar sort of command. The owner retains the 7, but we need to subtract 1 for the group and for everybody else. So 766, and let's have a look. And yes, it's done that. Read, write, execute is retained for the owner, but everybody else just has read, write permissions. What about now if we wanted to subtract writable permissions for the group and we wanted to subtract everything for everybody else? So the owner stays at 7, but we just want read permissions for the group. So that would be number 4, and we want nothing at all for everybody else. And we do an ls minus l, and there you go. Read, write, execute for the owner, read only for the group, and nothing at all for everybody else. So that's the chmod command, and use whichever variation you feel comfortable with. I very rarely use the numeric form because I'm constantly having to think, is it equal to 1? Is it equal to 4? To me, I just prefer, using symbolic representation, but completely up to yourself. So is that all there is to it? Well, ish. Most of us as desktop users will not really be going beyond this, but there is a separate category which we can call special permissions. And there are 3 types of special permissions that can be used. I'm not going to go into great detail on this, but I think it's worth understanding what they actually are. So let's look very briefly at special permissions, and we'll start by looking at something we call the sticky bit. This is a permission which is applied when we want to make sure that only the owner can delete or rename a file, even if everybody else has full read, write, and execute permissions. A good example of this is the temp directory, /tmp. Everybody can read, write, and execute in the temp directory, but we want to set the permissions on it so that only the owner, who's root, has permission to delete or rename a file. So we need to apply a separate permission, and we can tell if that permission has been applied because when we look at the mode bit in our ls-l output, the execute bit that would normally be set for everybody else, X, will show up as a T. So we know then that that has a sticky bit. Only the owner can delete or rename a file. And let's just quickly move to the command line and I'll show you what I mean. I'm actually, if I do a pwd, you can see I'm actually in root. So if I did an ls, you can see there's the main directories in the file system. But if I do ls-l and we move over to tmp, you can see there that it's classed as a directory and everybody within that directory has rwx, rwx, rwt. Right, so there's the sticky bit. This directory is owned by the root user and the group associated with root, but everybody has permission to read, write, and execute. But this sticky bit ensures that only root can actually delete or rename a file. How is that applied? Well, it's really quite simple. You just use the chmod command and you would do chmod plus T followed by the file name. And it would attach the T to the executable bit for everybody else. If you wanted to use the numeric method, that would be simple as well. Although the numeric method that I've shown you uses 3 numbers, 777, it's actually 4 numbers. It's just that for normal permissions, the first number is always 0. So regard 777 or 655 as starting with 0. So 0777 or 0655. If you were attaching a sticky bit, that first 0 would change to a 1. So the chmod command you would use to set up the permissions on the temp directory would be chmod 1777. On to setuid. Think about this a little in terms of the sudo command. What setuid does is it elevates a user's permission to that of the owner. It's only related to files. It has no effect on directories, this at all. But let me give you an example. A user can change their password by issuing the passwd command. Now that's quite interesting really, because the passwd command is owned by root. And okay, that's fine. We can run it as a normal user. But what actually happens when we do that is the encrypted password is then saved into the etc shadow file, and we do not have permission to write into the etc shadow file. But if we have setuid set on the password command, it elevates our permissions a little bit like sudo, and we get the ability to actually do that. So it elevates a user's permissions to that of the owner, but it doesn't have any effect on directories. Let's look again at the terminal, and I'll show you how this works in practice. If we try and look for the binary for passwd that we can action to change our password, you'll find it in usr bin. If I just do an ls-l on usr bin password, here are the permissions. Now, interestingly, what you'll see here is the user has these permissions: read, write, and something called S. The group has read permissions plus execute permissions, and everybody else has read permissions plus execute permissions. This S, which has replaced the execute bit for the group owner, which is root, sets the UID so that if a normal user attempts to execute this file, they are elevated to the permissions of the owner of that file. In other words, root. And as you'll see, this setuid permission actually appears right at the beginning on the execute bit of the owner's permissions. We can set it very simply. If you wish to, we would simply use chmod u, so it's the user, plus S to replace the X with the S that we saw, or using the same logic that I used before, if you want to apply it numerically. Let's say we had a file that was 777, we would put a 4 in front of that and do a chmod 4777. Right. Okay. So that's the sticky bit, and that's setuid. What about setgid? Well, it works in a similar way to setuid, but rather than elevating a user so that they had the same permissions as the owner of the file, processes implied by a particular file are run as the group that owns the file. So in this case, if you wanted to set it, rather than U plus S, you would do G plus S. And again, the S would replace the execute bit in the group's mode bit. It has a slightly different function if you set it on a directory. It means that all files that are created in the directory will be owned by the group of the directory rather than the file owners group. This can be quite useful if you're doing file sharing and you have lots of different users. All you need to do is make sure all of those different users belong to the group that owns those files. Phew. Right, so that's file and directory permissions in Linux. I hope you found that useful. I've tried to go through it in an A, B, C method so as to put everything together should you need this as a source of reference. And if you already knew all this, well, many apologies. If you didn't, hope you've gained something from it, but we'll leave it there for now. Have a great time, guys. I wasn't expecting to produce this video. I'm sort of working at the moment, but with a little bit more time at home, so it's still in the balance. So we'll see what else gets produced over the course of the week. Have a great day. Don't forget to join me on LBRY and come and join us on the Facebook group. Thanks, everyone.